Alright, welcome back. This is homework 22. This is the second problem. We're going to jump right in. Okay, so we are given this another box problem. This time the nails are screwed in the side and not the top. Okay, so the problem setup is very similar. You can check the last video for a more detailed explanation about the equations, but I'm going to mainly focus on the things that are different. So going in, we have these values that we've been given. Okay, so we have about the same formulas, right? In this problem, we are looking for the force and our S value, right? Our spacing, S, and the shear force, right? We're focusing on B. B just does the same thing as S, but looking at this, okay? So our S equation, as we have talked about last time, is that. Our other equation, force is equal to shear Q over I. Okay. Very similar. Okay. Now if we look at this, we have been given a force, and we've been given the shear, so we can go right ahead. That makes just everything a lot easier, right? So looking for that guy, we got that. Our Q is going to be slightly different in that if we look at the shape, let's see, I'm going to pull this up on a different clean thing. Okay, so if we look at the shape, right, it's about the same, except for this time we have, oh my, we have a setup that looks kind of like this. Oh, trying to make this a little cleaner, but oh my god. Okay. Oh, whoops. Like this. Yeah, that works. Totally works. Okay. So we have the nails going in here and here. So now what we're going to be looking at, we're looking at this inside shape. So we're just once again going to look at the top. That's what we're looking at. Okay, that is our problem guy right there. So this so happens to be a square, so the image doesn't quite match up. But if you can imagine this, let's use some more colors. We've got this, and we have this, okay? And that's where we're going to be looking at for shear, because once again, we're looking at the max shear, so it's going to be right in there. Okay, so if we look at this guy, our Q area Y bar, right, the area for that's pretty straightforward. It's just going to be that 6 inches by 1 inch, I believe, and that's right. Okay, and then for our Y bar, looking for this distance right here for our Y bar, right? It's still Y bar, it's not X bar, okay? Sorry for that confusion. So it's Y bar, okay? So then that's just going to be, it's our 8 minus 2, because you have 1 on each side, right? Divided by 2, and that's going to be 3, and then so that covers that distance, and then you just need, that covers this distance, and then you need that distance, which is just going to be 0.5. Minus 0.5 is 3.5, okay? So then that is going to be our Q value, okay? So going back, let's see here. So now we can just start plugging things in. We have our 12,000 times our 3.5, and then our I is the same thing as last time, where it's of the whole shape, where you have a rectangle minus a rectangle. So I'm just going to start plugging in those values. And again, it is a square, so it's pretty easy to do these guys. Cubed, it's a wonderful 3, 12. Okay, so then you're going to solve that. You're going to get 108 for your f value. Okay, and then from there, what they're asking for is we want to find what s is, the max spacing. Okay, the key is they give us that it can only hold a certain amount per screw, which is the force that 250 right there. So we're just going to jump to that. Let's get another slide for this. So if we know F is equal to 108, we know our S formula is equal to 2F over baby F. Then we have S is just equal to 2 times 250 over 108, which is then going to get us this 4.63 inches. And that's our answer. Okay, so if you guys have more questions about what Q is, just go to the previous video for the homework 22 set.